In this video, we'll be exploring what a catalyst is and how it's used in a chemical reaction. Starting off, what is a catalyst? Officially, a catalyst is defined as a substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. There's some important stuff to unpack in that sentence. First off, the most important thing which you must know about a catalyst is that it always increases the rate of a chemical reaction. Using a catalyst in a chemical reaction will allow you to form your products quicker than if you were to proceed without one. This is because catalysts provide an alternative reaction pathway with a lower activation energy, which allows more successful collisions. The other important thing you need to know is that catalysts are only temporarily changed during a chemical reaction, but will always have the same ending shape as starting shape. So any change they undergo during the reaction is not permanent. It's always going to be reversible. Now, there are theoretically an infinite amount of catalysts, and they take many different forms. For instance, you may remember from biology that enzymes are catalysts. What an enzyme does is it provides an alternative reaction pathway with a lower activation energy, which, as we covered in the last video, the lower the activation energy, the faster the reaction. Another catalyst you may be familiar with is the catalytic converter in a car. That's the thing people are always trying to steal. You already know that cars expel carbon dioxide, which is pretty bad because it's heating up our planet. But actually, this is the best case scenario because carbon dioxide isn't what cars naturally expel. Naturally, they create carbon monoxide, which is an insanely flammable and toxic molecule. It's very bad for the planet. In nature, carbon monoxide naturally becomes carbon dioxide, but this chemical reaction is kinetically slow. It takes a very long time to happen, and it'd be bad if carbon monoxide was constantly building up in the atmosphere. So instead, we use a catalytic converter to speed up the reaction. A catalytic converter decreases the activation energy needed to turn carbon monoxide into carbon dioxide. And so the main takeaway from all this should be that we use catalysts to reduce the activation energy of a reaction and speed them up. Now that we know what a catalyst is and why we use it, I need to show you how it changes the reaction profile of our reaction. In the last video, we talked about reaction pathway graphs. The following graph shows the reaction path for a chemical reaction. And as you can see, there are two different lines. For now, only pay attention to the black one. That's the one you're most familiar with because it's the one that shows the natural reaction taking place. As you can see, the activation energy for this reaction is quite large. The difference in potential energy between our starting reactants to reach our transition state is quite a lot. And so because the activation energy is so high, this is going to be a pretty slow reaction. Thus, if we want to speed it up, or we just want to put less energy into this reaction, we can introduce a catalyst into the reaction. The red line shows our reaction after we've introduced a catalyst. Like we said, the catalyst is now providing an alternative reaction pathway. And as you can see, the activation energy for the catalyst reaction pathway is much lower. Again, to find the activation energy, we go from our reactants to the highest point of energy, and we see that this difference is much smaller than our blue line. And so again, that's why this catalyst is useful. A common misconception that students sometimes make is that if you have multiple humps, like for our catalyst reaction pathway, you have to add activation energies together to get an overall activation energy. That is completely incorrect. You should never be adding activation energies with one another. To find the activation energy, we're just looking at the highest peak on our graph. The highest peak represents our activation energy. Because if we've got enough energy to make it over that high peak, we've got enough energy to make it over all the lower peaks that come before or after it. So just make sure to keep that in mind. And with that being said, that's all you have to know for catalysis in AP Chemistry. If any of this was confusing, I recommend rewatching parts of the video. If it's still not making sense, take a break and come back after. Thank you for watching.